There are 4 different kinds of changes that we will make to our basic graphs of sine and cosine. And one of those changes is what we call the change in amplitude. Remember, amplitude is the vertical distance from the middle of the graph to the top of our graph, and from the middle of the graph to the bottom of the graph. Another way of saying that would be it's half the difference between the maximum and the minimum values. The amplitude is changed when we multiply the front of the function or the outside of the function by some value. The amplitude itself is always considered to be positive. It represents a distance. To see how multiplying the outside of the function by a value, how it affects the graph, let's look at y equals 2 times sine of x. So here we have our x values, and we're going to plug them into our function. So that would be y equals 2 times sine, and we're going to use an x value of 0, which gives us 2 times our sine value at 0 would be 0, so we get 0. So our first point that we're going to plot is 0, 0. If I have pi over 2, we're going to plug our pi over 2 into the sine function. Sine of pi over 2 is 1. 2 times 1 is 2. So now we have pi over 2 comma 2. Now we're going to use pi as our x value. The sine of pi is 0. 2 times 0 would be 0. So we're going to plot pi comma 0. 3 pi over 2, find the sine value of 3 pi over 2, we get minus 1. 2 times minus 1 is negative 2. So we get 4 points so far. And the last point that we want to plot, 2 pi is our x value. The sine of 2 pi is 0. 2 times 0, we get 0. So 2 pi comma 0. So we're going to plot these points and we're going to compare it to the original basic shape of the sine function. Since we multiplied the front of the function or the outside of the function by 2, we would say that the amplitude is 2, and the period of the function hasn't changed, so the period is still 2 pi. Now we have found 5 points for y equals 2 times sine x, and we want to compare this to the original basic shape of sine. So what we found was y equals 2 sine x, we got a point 0, 0. And pi over 2, we got to 2, so a positive 2. At pi, we were back to 0. 3 pi over 2, we came down to minus 2. So here's minus 1, minus 2. And then at 2 pi, we came back to 0. So what we see is that the graph is vertically stretched. So instead of having an amplitude of 1, we actually now have a vertical distance from the middle of our graph to the top. The vertical distance is now 2. And from the middle of the graph to the bottom, that vertical distance is also 2. So the graph is stretched by a factor of 2. So if we were to keep going with this, the x-intercepts would still be the x-intercepts, and the maximum and minimum values of our graph would be 2 and negative 2. So we could keep going with this in both directions. So changing the amplitude of our graph, changing the value that's being multiplied on the outside of our function, stretches our graph and changes the amplitude of the original basic shape. We would see that changes that are made to the outside of the function will affect our graph vertically. So they will either vertically stretch our graph or vertically shrink our graph. In other words, it changes the y values that are used for the graph. What if I multiply my cosine function on the outside by negative 3? We want to see what happens when I make that change to my cosine function. So we're going to use these as our x values, our angles. So y equals -3 times cosine of 0. Well, the cosine of 0 is 1, so we have -3 times 1, and we get -3. Cosine of pi over 2, so we have -3 times, and the cosine of pi over 2 would be 0. -3 times 0 is 0. We're going to do the same thing here with pi. The cosine value of pi is -1. -3 times -1 is a +3. The cosine value of 3 pi over 2 would be 0. -3 times 0 is 0. And now back to 2 pi. The cosine value of 2 pi is 1. -3 times a +1, we get -3. So now let's plot these points and see how the graph is affected. First of all, the amplitude of our graph, the number that's being multiplied times the front is -3. Remember that amplitude is always considered to be a positive value, so we take the absolute value of the number that's being multiplied times the front of our function, so the amplitude would be 3. So the vertical distance from the middle of the graph to the top and the middle of the graph to the bottom will be a vertical distance of 3. What does this negative do? If the amplitude is considered positive, what does this negative do to our picture? What we're going to see is that it's going to take the basic shape of our cosine function and it's going to flip it upside down. So I'm actually going to have something that looks like this. It takes that basic shape and flips it upside down. So let's come down and see what it looks like when I graph y equals -3 cosine of x. The period is still 2 pi, that hasn't changed. So we're using those values, we're going to plug them in, and let's label some points. We have 1, 2, 3, -1, -2, -3, and we're going to label our 4 equal segments. We have pi over 2, 0 pi over 2, and then pi, 3 pi over 2, and then back to 2 pi. When I start to plot my points, we have -0, -3, pi over 2, 0. We had pi, +3, 3 pi over 2, 0, and then 2 pi, -3. So we see that the basic shape of our cosine function has been flipped upside down. When we flip that upside down, we start with a min, and then we get to the x-intercept, and then we achieve the max. Back down to the x-intercept, and then we achieve our minimum. So multiplying the front of the function by a negative value will flip our basic shape upside down, and we'll reverse it in a vertical way. But the basic shape is still there, but it just gets flipped upside down. And notice that our amplitude of 3 has stretched our graph. The distance between the middle and to the top of the function is now 3. From the middle to the bottom is a distance of 3. And once again over here, also a vertical distance of 3. Here we want to look at 2 more examples of a change in amplitude. Here we want to graph y equals 4 times cosine x. So we've multiplied the outside or the front of the function by 4, so the amplitude will now be 4. That means that my graph will be stretched by a factor of 4. So let's go ahead and label our graph here. It's a positive 4 in front of the function, so we do not have a flip. the period of the function is still 2 pi. So when we go in and label our x values, we'll still have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So remember that the basic shape of cosine starts out at the max, and now the maximum is stretched to a vertical distance of 4. We come back down to the x-axis, and then at the middle of our graph we've achieved the minimum. We're going to go all the way down to -4 for that vertical stretch, that change in amplitude. Back up to our x-axis at 3 pi over 2, and then the last point will be back up to the maximum value of 4. So we see that our amplitude has affected our graph and stretched it a distance of 4 units from the middle of the graph to the top and from the middle to the bottom. Now we want to graph y equals -2/3 sine x. So first of all, our amplitude is the absolute value of the number that's being multiplied times the front of my function. So the amplitude is actually 2/3. The period is still the same, it's still 2 pi. And since our amplitude is 2/3, we know that our graph will be compressed vertically to be a distance from the middle to the top and from the middle to the bottom of 2/3. Since our period is still 2 pi, we will label our points from 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. And the basic shape of our sine function, we remember, starts at the x-axis, achieves a max, goes back to the x-axis, then achieves a min, and then comes back to the x-axis. Now, because we have a negative that's being multiplied times the front of our function, this negative is actually going to flip the graph upside down. So we'll start at the x-axis, and then we'll go to the minimum, come back to the x-axis, achieve a max, and then come back down to the x-axis. So we'll start at the x-axis, and then at pi over 2 we will go down to the minimum of -2/3, and then back to the x-axis. And then for our fourth point we will be at the max of +2/3, and then for our last point we will come back down to the x-axis. So our amplitude has compressed our graph to be a vertical distance of 2/3 from the middle to the top and from the middle to the bottom of our graph.